Hi guys, I'm just going to post the link onto our page and then we'll start in about 20 seconds. We're going to have an event on linear quadratic. I'm just typing away on the Facebook page. So those of you who are not familiar with the format, we're going to have this session on YouTube Live and on Facebook. So on Facebook, we'll post the questions and solutions. We'll be posting the link of YouTube there. Right? And further plan being told clearly by my team many times over to make this very explicit, very clear. We want to have a bunch of sessions on Google Hangouts via YouTube, and we're going to have cover topic by topic over the next few weeks. And the idea is to cover as many topics as possible, going at the rate of one per week. So we're going to cover quant, we're going to cover DALR also at some point in time. We will probably try to squeeze in verbal as well. So as ever, anytime you have queries, doubts, questions, do post them. We will get them clarified as soon as possible. Those of you who are not familiar with the format, we're going to have this event live on YouTube. We'll be posting a bunch of questions by sharing the screen and then be discussing them. We'll go reasonably slowly and do it thoroughly. The questions will get posted standalone on Facebook and our Facebook group as well. From Facebook, you can click on the YouTube link and click there. And the plan going forward is to have the session every week or every other week, covering one topic every Saturday around 10 or 10:30, depending on which one works better. So we'll have a 1 hour session every Saturday. Okay? I'm going to switch off and go on to screen sharing mode so that we can discuss the questions. Again, the questions will get posted on FB as well. And remember, we plan to have this every week. What we plan to have is to pick a topic, start posting interesting questions from that topic from Thursday onwards. So Thursday, Friday, Saturday, we'll post questions on FB and answer them and discuss them, get the topic ready. On Saturday, do a set of 8-10 questions, which we'll discuss live on YouTube and post a link on FB. Post this, these questions will also get posted on FB the subsequent week. The idea is between YouTube and FB, we take one topic per week, run a schedule from Thursday to Friday with a live session each Saturday. So that's the plan. So just this alone should get you for CAT if you're done with your basics. Of course, basics can't be done that easily on a bunch of live sessions. So get your basics done, but otherwise, this is good going. Okay. Wonderful, guys. I'm going to switch out of this, go to Hangouts, do some screen sharing, and then we should be good. I'm going to share the screen. So I'm going to get out of the place and we're going to discuss questions here. Right. That is the first question. So have a look at that. I'm going to give you about 5-10 seconds not 5-10 seconds, that is too short, it is absolutely cruel. I'm going to give you about half a minute to go through the question. Subsequent questions will also get posted on FB. The first questions we have not posted it that quickly. So other questions will get posted slightly ahead of schedule on FB. So if you finish one question, you don't twiddle your thumbs, go on, grab the next one. Super guys, give this a go. This is a question on linear equation. This is a classic template. There's nothing fantastically new here, but there's one simple idea of how to crack this. And then we'll discuss that template, that idea, and then go to the next one. There's nothing new here. It's not impossibly tough. Very regular, very doable. Give this a go. And a bit of a clue, I'm going to say, look, this does not look like a linear equation that we know. Whereas we're dealing with linear equations. So this question is from linear equation, but this one does not look like a linear equation. Right? So figure out a way to transform this into a linear equation, to make this look like a linear equation. Pick some pattern sitting there. And so there's not a linear equation in x and y. And so that's because there's a 1 by something there. But there are x minus y and x plus y terms. So maybe we can coin it into a linear equation in some other variable and then come back to this. So how would that method work? You would simply say, look, let's just say 1 by x minus y equal to a, 1 by x plus y equal to b. So this becomes 3a plus 8b equals 7, 13a plus 10b equal to 8. Voila, now we're done. Now 3a plus 8b equal to 7, 13a plus 10b is equal to 8. Got these two. Now these two are plain vanilla beautiful linear equations. Solve, get a and b, and then put 1 by x minus y is a, 1 by x plus y is b, or x minus y is 1 by a, x plus y is 1 by b, and then solve for x and y after that. So we're going to do this is two sets of linear equations. Use linear equation, solve, get to the answer, and then do one more round. How do we solve linear equation? Eliminate one variable, 3 and 13, 8 and 10. I'm going to eliminate b. So multiply this by 5, multiply this by 4. So 15a plus 40b equals 35. 13 into 4, 52a plus 40b equals 32. Wonderful. Subtract one from the other. This disappears completely. 15a minus 52a. 52 minus 15, whatever that turns out to be. This is 37a is 3. Not just 3, it is minus 37a is 3, or a is minus 3 by 37. I hope I've done the math right. Into 5 is 15 plus 40, into 4 is 52 plus 40. 7 into 5 is 35, 8 into 4 is 32. Subtracting that gives us 3. That is all right. In this case, we are subtracting 15 from 52. What is the negative sign? So a is minus 3 by 37. Substitute that here. 13 into minus 3 by 37 plus 10b equal to 8. Or 10b equals 8 plus 39 by 37. 10b is 6, 5, 24, 29, 296 plus 39 by 37. And so 296 plus 39, 5, 1, 4 plus 9, 13, 3, 1, 335 by 37 is 10b. 2b is 335 by 5, 67. B is 67 by 74. So we know A is minus 3 by 37, or x minus y is minus 37 by 3, x plus y 74 by 67. Add these two, find x and y, then you simplify. We're just discussing ideas, so I'm not going to do this elaborately. We can find the LCM and simplify and find the answer. I'm not going to solve that. I hope I've done the algebra right. Just pick this question and I've had a crack at it. So you simplify this, add these two equations, we'll get 2x, subtract one from the other, we'll get 2y. If you have 2x and 2y, you can find x and y. It's not rocket science. Very doable question. Key idea here, if you've been constructing something if you construct something in terms of 1 by x minus y and 1 by x plus y, you get linear equations. Then once you have the linear equations, all you got to do is simplify that, solve that, and get the answer. And so this is not a question with linear equations in x and y. This is a question with linear equation in 1 by x minus y and 1 by x plus y. Solve those two, get to x and y. Go to the next question. This one. Again, I'm going to give half a minute or 1 minute, go through that, and then we'll get cracking. solve this one again. Linear equations, plain and simple. Wonderful question. Just using the simple idea on averages, nothing more than that. Right? So, average of two numbers A and B is D. Average of D and C is 2 more than average of A, B, and C. What is the difference between C and average of A and B? Average of A and B is D. You want to find a difference between C and D. So, I'll write this down. This is the framing of the equation part is interesting. Right? We know that A plus B by 2 equals D. We know that average of D and C is 2 more than the average of A, B, and C. So D plus C by 2 equals 2 plus A plus B plus C by 3. And what do we need to find? We need to find C minus D. Either C minus D or D minus C. And depending on the choices, whichever is positive, we'll go for that. Looking for modulus of C minus D. What is the difference between C and the average of A and B? So you can simplify this as A plus B equals 2D. D plus C equals 2 plus A plus B plus C by 3. Average of D and C is 2 more than average of A, B, and C. So I'm going to take this as a by 2 here, by 3 here. I'm going to multiply the whole thing by 6. So you get 3D plus 3C plus 12 plus 2A plus 2B plus 2C. We need to find the difference between C and D. So let's see if we can construct something which incorporates C and D specifically. We need to find C minus D. So we need to find 2A plus 2B. We have A and B here. Very interesting question. You can form lots of equations. But if you remember that we are doing C and D together, we know that A plus B is 2D, or 2A plus 2B is 4D. But think about this. 3D plus 3C equals 12 plus 4D plus 2C. Let's bring all the C and D to one side. So this is 3D minus 4D plus 3C minus 2C equals 12. Or this is D minus C equals 12. Or the difference between C and the average of A and B is 12. What about this question is there's 4 variables A, B, C, and D. And so we not be able to absolutely solve them and get all values. And so we know A plus B by 2 is D. We know D plus C by 2 is 2 plus A plus B plus C by 3. So reasonable equation and a complicated equation. Solving for A, B, C, and D from this and then trying to find C minus average of A and B doesn't work. There's every chance that there's not a unique set of numbers that satisfies this. So we cannot find A, B, C, and D. When you're given simple plain linear equation, you could be asked to create something or gather something, pick up something that's a combination of a bunch of these things where you just combine and manipulate and get through. Key thing to realize is here we're looking to find difference between C and D. We're looking to find an equation which either finds as D minus C or finds as C minus D. So you're looking for that. You're looking to somehow take off the A's and B's and bring it back to the C's and D's. That's what you're looking to do. So very often these kind of questions, if you know what you're chasing, life becomes simpler. This question becomes ultra easy if you write 2A plus 2B as 4D. Why would I go about thinking like that? That is important. So it's very easy to follow a solution. I'll say 2A plus 2B, put it as 4D, I've got the answer. That's easy. Nothing more rocket science there. Next question like this, you've got to realize that some 2M plus 2N has to be written as 3P. Why are we looking to do that? We want to find C minus D. This equation has a D, a C, A, B, and C. But an A and B, funnily enough, can be written in terms of D. Therefore, let us give it a go. It might not work, but let's try that. So the idea is to construct in terms of D and C, so know what you're chasing for. So otherwise, this becomes a wild goose chase. Keep that in mind. Again, I'm going to give about a minute and a half to try this question, and then we'll discuss this. In a school, there are 3 classes A, B, and C. If 10 students are shifted from B to A, then A will have 3/4 the number of students that are present in C. If 10 students are shifted from C to A, then B will have as many students as A and C put together. If 20 students are shifted from B to C, then C will have thrice as many students as A. What is the average of the number of students in A, B, and C? It looks like we've been given three sets of equations. Remember that two of those equations can combine to give us a third. Therefore, it looks like we've been given three independent equations. That's why I'm saying it looks like that. Right? Also remember that we're looking to find A plus B plus C by 3. We want to find A plus B plus C by 3. Or we want to find A plus B plus C. So once you write down the equations, perhaps you might not have to solve everything. Perhaps you can just add two equations, subtract one, you'll get A plus B plus C. So have a clear idea of what you're looking for. That usually is very helpful. Give this a go. I'll give a minute and a half tops. I want to discuss as many questions as possible, so I'm not going to push it away. So I want to have this class for about 45 to 50 minutes, run this through, then have a 10-minute discussion on how to prepare for linear equation, quadratic equation, and then wind up. But we want to cover as many questions as possible, so I'm going to be finicky about this. Minute and a half tops, and then we'll discuss this. Those of you who feel like you need more time, you're not listening to a class inside your regular brick and mortar framework. We're doing this over the wonderful internet thing. So shut up the teacher, put pause, then try the question, and then continue. Your live session will work on a 10-minute delay. That's what the recording live YouTube framework is for. These days, I don't even watch football matches live. Pick up in the middle of the night to watch a football match. I don't want to sit through that 15-minute break, so I record it and start 15 minutes later. So simple trick. So make sure that you have you do these questions at your pace. It's a good question, especially this one is a wonderful question. So if you're not ready completely, then hit pause, try this, solve it, get through to the answer, then see the video. The video does not look like it's saying something fantastic, skip it, catch back with the next question. So we've had enough time. I'm going to have a go at this. 10 students are shifted from B to A, then A will have 3/4 the number of students. Then let's say initial number of students in each class equal to A, B, and C. Initially, the A students, B students, C students in the class. 10 were shifted from B to A, so A will now become A plus 10. A plus 10 equals 3/4C. 4A plus 40 equals 3C. We've got one equation, brilliant. The next one, if 10 students are shifted from C to A, then B will have as many students as A and C put together. You go from C to A, that means A will increase, C will reduce. Doesn't matter whether there are 10 students or 15 students. How many ever you take from C to A plus C will remain the same. B will have as many students as A and C put together, or B equals A plus C. From C to A, we would have written as A plus 10 plus C minus 10 equal to B. B will have as many students as A and C put together. B equals A plus C. If 20 students are shifted from B to C, then C will have thrice as many students as A. C will have thrice as many students. Shifted from B to C, so C will become C plus 20 equals 3. C plus 20 equals 3A, and 4A plus 40 equals 3C. If we use these two, we'll be able to solve and get A and C. Once you've got A and C, plug it in and we get B. So this is a simple equation. Three simple equations, just have to construct them well. 4A plus 40 is 3C. C plus 20 is 3A. Let's solve these two. So we can say C is 3A minus 20. So 4A plus 40 equals 3 times 3A minus 20. 4A plus 40 equals 9A minus 60. 100 equals 5A. A equals 20. C plus 20 equals 3 into 20. C plus 20 is 60 or C is 40. B is A plus C, B is 60. What is the average of A, B and C? So it's 20 plus 40 plus 60 by 3. 20 plus 40 plus 60 by 3 is 120 by 3, which is 40. And so, simple question, frame the three simple equations, manipulate them here and there, you will get it. There are two simple equations in A and C. Solve those two to get A and C. Plug it back into B equal to A plus C, we've got B as well. Once you've got all three numbers, find the average. Let's go to the next one. That's over. Take some time, a minute and a half, and then we'll discuss this one. Just going to recap the theory. A1x plus B1y equal to C1, A2x plus B2y equal to C2. For this to have a unique equation, so just we have these two equations, then A1 by A2 not equal to B1 by B2. This will give us unique equation, unique solution. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. This means you've practically been given the same equation twice over. That means there'll be infinite solutions. You have A1 by A2 equal to B1 by B2, but not equal to C1 by C2. And there are no solutions. Two equations, instead of being identical, just a constant term is shifted out. So therefore, there'll be no solutions. Coordinate geometry wise, visually, how do we think about this? These two are two intersecting lines. These two are two identical lines. So one line drawn twice over, like saying x plus y equal to 2, 2x plus 2y equal to 4. Practically the same equation given twice over. This one, these are parallel lines. So instead of same equation given twice over, pushing one out a little bit. So saying x plus y equal to 2, 2x plus 2y equal to 5. X plus y is 2, means 2x plus 2y is 4. You think 2x plus 2y is 4 and 2x plus 2y is 5. 2x plus 2y cannot be simultaneously 4 and 5, or it's impossible to satisfy these two equations, or there are no solutions. You should know these rules, should know the funda behind the rule, should know why this works, should intuitively understand that we're talking about intersecting line, coincidental line, and parallel line. So let's look at this. Which of the following could be true? A1 B2 equal to A2 B1. This means A1 by A2 equals B1 by B2. This cannot be true. If this were true, then this system cannot have unique solution. It can have infinite solutions or no solution, but this cannot be true. Next one. C1 B2 equals C2 B2. C1 by C2 equals B2 by B2. Either C1 is equal to C2 or B2 equal to 0. Both are all right. C1 could be equal to C2. You will have a unique solution. And you can say x plus y equal to 7. 2x minus 3y equal to 7. That will work. Why will it not work? That can give us a unique solution. Right? So this could be true. A2 equal to 0. A1 into B1 into B2 not equal to 0. Basically saying B1, A1 and B2 are all not 0. Saying B2y equal to C2. This will get y. And then A1x plus B1y equals C. Not 0, not 0, not 0. We have this value of y, substitute that back, we'll get a value for x. Again, you can have a unique solution. You will have a unique solution to this could definitely be true. Statements 2 and 3 are both potentially true. Both could be true. So 2 and 3 could be true, but not statement 1. The conditions are important for unique solution, infinite solution, no solution. And the way of visualizing it and then kind of imagining it your own way, that is important. But otherwise, there's nothing to it. Jumping on to quadratic equations. Again, give this a go. We'll discuss this one. The roots of the equation x square minus bx plus c equal to 0 be two consecutive integers. Then b square minus 4c equals what? That's what the question says. If the roots are two consecutive integers, two adjacent integers, m and m plus 1, k and k plus 1, then b square minus 4c equals what? Give this a go, we'll discuss it. Square minus bx plus c equal to 0. That is b square minus 4c. And that's very suspicious, very wonderful expression. Where have we heard this before? B square minus 4ac is the discriminant. So b square minus 4ac, this is in this question, this a is 1. Or this is a discriminant. So I'm going to say, what does this equation give roots as? You should know that big formula. And so that big formula is roots of the equation are minus b plus or minus root of b square minus 4ac by 2a. In this question, b is minus b, a is 1, c is c. That's what this becomes. So our roots will be b plus or minus square root of b square minus 4c by 2. So it is nothing but b plus square root of b square minus 4c by 2 and b minus square root of b square minus 4c by 2. They are consecutive integers. So one root minus another root should be equal to 1. The difference between the two roots is 1. If you notice, the b will completely disappear. We'll have 2 times square root of b square minus 4c by 2 equal to 1. Square root of b square minus 4c is 1, or b square minus 4c. And the difference between the roots is just 2 times square root of b square minus 4c. That is minus b plus or minus square root of b square minus 4ac by 2a. In this case, a is 1. So you're effectively subtracting one root from the other. The answer should be 1. That's what it's saying. 2 consecutive integers. That's what the roots are. So the difference between the 2 roots is 1. They're effectively using that idea. The difference between the 2 roots is 1. And you'll get b square minus 4c to be 1. We'll go to the next question. Really tough question. I'm going to skip this one. I don't think that's something that we need to worry about. Try this one. Very routine question. It's a classic question. Should nail these kind of questions. You should just rush through this. I'm going to give you a minute, minute and a half, and then rush through the solution. Do it like that at full top-notch speed, so that you get used to the idea that these are the kind of questions which you run on autopilot. In your exam, you'll get some thinking questions. You'll have to figure out and be careful about it. Question on permutation, combination, you have to worry about accounting for everything. Get a question on geometry, you have to think about which theorem to use and rack your brain. To get a question on quadratic equation like the previous one, or the linear equation like the one that we saw a couple of questions ago, then you have to worry about how am I going to find this? What am I going to find? You're going to think through the question and then manipulate. This one, you should see this question, I should light up. Just I'm knocking down. I should just switch off and knock this out. This is kind of, to give you a cricket analogy, it's the middle overs. No swing, no seam, the 2 diddly bowlers bowling, you need to knock 5 singles in over. Right, so middle overs on a modest target. So no risk, knock it off, go to the next one. You've got to get it right and rapidly, but there is nothing to do this. And if you don't get this right time after time and really quickly, you just pick up a book and do 100 questions. Some get to that level in 10 questions, some take 20, some take 60. You do the number of questions it takes you to get it right. I'm not the players. Super. Let's run this. To start with the theory, if you have an equation ax square plus bx plus c equals 0, the roots are m and n, and sum of the roots m plus n is minus b by a, product of the roots m n plus c by a. Let's get to this one. Roots p and q, so p plus q equal to 8, p into q equal to 12. Got this. Then we've been given this other equation that has roots p square plus q square and 2pq. If you can get what p square plus q square and 2pq are, we are through. Then we can write this down. So 2pq is 24. Life is good. We already got one thing. P square plus q square. P plus q whole square. P square plus q square plus 2pq. So p square plus q square plus 2pq. This is 8 square equals p square plus 2q square plus 24. P square plus q square. 64 minus 24, 40. So the root should be 40 and 24. Equation should be x square minus sum of roots times x plus product of roots equal to 0, or x square minus 64x. A and B. A should be sum of the roots 20 and 40 and 24. Add up, we'll get 64 plus 24 into 40 equals 0. Or A equals minus 64. B equals 24 into 40. 24 4s are 96. This is 960 is B. A is 64. 960 minus 64. Whatever that turns out to be. I hope I've not done any computational mistake. Conceptually, there's nothing to this. And so, if I've indeed made some computational mistake, I'm not saying, I'm doing a practice class online. I'm not doing the exam. So, you cannot afford to get any computational mistake. You cannot afford to get this wrong because you've done 4 into 5 is 19. And so, I can. I'm going to give myself a wriggle room. So, even if I've got this right, you should get it right. Even if I've got this wrong, you should get it right. And so, simple question, know sum of the roots is given an equation, how do you find sum and product? Given sum and product, how do you find equation? Both are important skill set, simple skill set, simple ideas. Once you have that, you should just say, look, folks, I know how to do this question. Why should you mail it? This is a tough one, so take your time, get it right. I'm going to give 2.5 minutes for this. Try this and get it right. I always like it when we have a question where we can deal from first principles. So this is a classic question like that. So x squared plus 4ax plus 10 minus 3a is greater than 0 for all real values of x. And what is the range of values a can take? So basically, it just says that this works for all real values of x. What does this mean? So I'm going to break this one. I'm going to be very particular about this question because it's a fabulous question to discuss the ideas. I'm going to say, let me put a equal to 1. We figure this out. X squared plus 4x plus 10 minus 3 greater than 0 for all values of x. Does this work? I know this has nothing to do with the question. I'm going to go down with this. But just say x squared plus 4x plus 7 greater than 0 for all values of x. I don't even know whether it works. I'm going to see and say, does this work? Can a take the value of 1? Is a equal to 1? Does it really work? That's what we're going to try to find out. Now, x squared plus 4x plus 7, is it always greater than 0? So how do you reconstruct this? X squared plus 4x plus 7. X squared plus 4x plus 4 plus 3. Why am I written like this? Why am I thinking of 7 as 4 plus 3? That's what this question boils down to. X squared plus 4x plus 4. This is x plus 2 whole square plus 3 greater than 0. Does this hold good? Of course it does. X plus 2 whole square greater than 0 for greater than or equal to 0 for all real values of x. Plus 3. This will always hold. So a equal to 1 works for us. Let's look like there's an equation in terms of x and a. They say all real values of x. What does it mean? So suppose we put a equal to 0. We'll do one more. Just get the hang of this thing. That means x squared plus 10 greater than 0. 4ax goes to 0. 3a goes to 0. Does this always work? Does it work for all values of x? X squared plus 10. Will it always be greater than 0 for all real values of x? Yes, true. This is a square. It cannot be negative. Plus 10. Obviously, it cannot be. It will be greater than or equal to 10. Forget 0. This always hold good. And the beauty about this question is now we can wind our head around it. We can put different values of a. It looks like for different values of a, this indeed holds good. Maybe I put a equal to 3, a equal to 10, does this hold good? Put a equal to minus 5, does that hold good? If a equal to minus 3, does that hold good? I can try that. But what am I trying to say here? If I put a value of a, then I get an expression in x. And that is supposed to be greater than 0 for all values of x. Whenever you have greater than 0, then it always helps. You can say that y square plus 5 is always greater than 0. You can say z square plus 3 is always greater than 0. It helps if you can isolate a square, an expression. You say x plus 3 whole square, y minus 5 whole square, z plus 7 whole square. If you can extract that, you're through. Now let's see how we can extract that. So this question, now we're going to deal with a. Let's say x square plus 4ax is greater than 3a minus 10. Why am I doing this? This has x and a, this has only a. I'm going to keep this out. I'm going to extract a's out of the system and deal only with x's or in expression in terms of x. For different values of a, this becomes like a constant. X square plus 4ax. I'm thinking of x plus something whole square. And I'm going to end with x square plus 4ax plus something. What should sit here and what will sit here? Think about this very important idea. X plus k whole square is x square plus 2kx plus k square. We need a 4ax. Should be x plus 2a the whole square. Should be 4a square. So this is a perfect square we're looking for. I'm going to stick that in here. I'm going to say x square plus 4ax plus 4a square is greater than 4a square plus 3a minus 10. So far so good. 4a square plus 3a minus 10. X square plus 4ax plus 4a square is greater than this. Now this is x plus 2a whole square is greater than something. When will it hold good for all real values of x? This number is negative. X plus 2a whole square is going to be greater than any negative number. Any negative number we have, x plus 2a whole square will be greater than any negative number. It could be 0.000001. X plus 2a whole square will be greater than that. So effectively, we're solving for 4a square plus 3a minus 10 less than 0. Beautiful. I'm adding 4a square on both sides. And once I have done that, I'm dealing with 4a square plus 3a minus 10 on one side. X plus 2a whole square should be greater than this number. If this number that we're dealing with were negative, we're through. Then this number, if it is negative, let's say it is minus 3, is x plus 2a whole square greater than minus 3. Does this work for all real values of x? Of course it does. So square on one side, negative number on another side. We are through. So now let's solve this. 4a square plus 3a minus 10 less than 0. 4 into minus 10 is minus 40. So if we split this to get minus 40, 4a square plus 8a minus 5a minus 10 less than 0. 4a into a plus 10 minus 5, a plus 2 minus 5 into a plus 2 less than 0. 4a minus 5 into a plus 2 is less than 0. The roots of this equation are a equals 5 by 4, a equals minus 2. And quadratic in a is less than 0. It has two roots, 5 by 4 and minus 2. Or if a lies in the range minus 2 to 5 by 4, then this equation will hold good for all real values of x. Wonderful. What does this mean? This means that if a is in this range and we plug in a value of a there, then we can extract a square in terms of x and then have a negative number on the other side. That means that will always hold good. Say x plus 3 whole square greater than minus 3. Will it hold good? Of course, yes. X plus 7 whole square greater than minus 8 will always hold good. So we are playing for that, for constructing an equation where this holds good. Right. I'm going to discuss outline for another method to do this. X square plus 4ax plus 10 minus 3a. Draw the graph for this. It's going to be something like this. An equation in x square is going to be a graph like this. A graph like this, where it hits the x-axis. What does it mean? This is going to be some a comma 0. This is going to be some b comma 0. This is going to be some q comma 0. And if you think about this, if you put x as 0, the expression will, x is p, the expression will go to 0. X is q, the expression will go to 0. Or the roots are p and q. Right? So we are told x square plus 4ax plus 10 minus 3a is greater than 0 for all real values of x. So the graph cannot be like this, because if the graph were like this, then there are values for which this expression becomes equal to 0. This quadratic that we seem to be dealing with, if it has roots, real roots, then we are in trouble. And for those real roots, this expression will be equal to 0. Then in between those two real roots, somewhere it can go below 0. So therefore, we are looking to solve an expression which says this particular quadratic expression has no real roots. What does that mean? The discriminant for this quadratic in x is greater than 0. So find that discriminant. B square minus 4ac greater than 0. That will be an expression in A, or a quadratic in A. Take that quadratic in A, simplify, solve that. So that's another way of solving this. When you're told that a quadratic in x, just some other variable is greater than 0, basically means that has no roots. Equal to 0 does not have solution. It's consistently greater than 0 for all real values of x. Other way of stating, for no real value of x is it negative. For no real value of x is it 0. That means if you put it equal to 0, you will not be able to solve and get values of x, or this has no real roots. The roundabout way of saying this particular equation does not have any real roots. It does not have any real roots or discrete roots. And the whole thing correctly, then all this right, we're solving for the expression that discriminant should be less than 0. It has no real roots. That means discriminant should be less than 0. Getting old. Right? So the discriminant there should be less than 0, not greater than 0. So you can think of it as a quadratic in x, which has coefficients in terms of a, for which the discriminant should be less than 0, and then solve for the discriminant, which will turn out to be a quadratic in A. Simplify that inequality, you'll get the same range. That's the other way of approaching this question. Let's go to the next question. Try this one. Again, I'll give you a minute and a half. Give this a go. We'll discuss this one. This is a very routine question. You'll get questions like this. Remember that. This is a standard fact. If we're given roots A and B, then we know sum of roots and product of roots. We know A plus B, we know A into B. So look to find A plus B and A into B, and then you should know any expression in terms of A plus B and A into B is part of the course. So find that, and then you're through. And this is sum and product, sum of roots, product of the roots, written all over it. Very routine question. Kind of question where you just switch on and say, look, I know this, and then nail it. By this, sum of the roots A plus B is going to be 12. A into B is Q. A cube plus B cube. I write it as A plus B into A square minus AB plus B square. Or you can say A cube plus B cube is A plus B whole cube minus 3AB into A plus B. Both ways are fine. You can say A cube plus B cube equals A plus B whole cube minus 3AB into A plus B. Another way of writing this down. A plus B whole cube minus 3AB into A plus B, or like this. This is nothing but 12 into A plus B whole square minus 3AB. A plus B whole square will give us A square plus B square plus 2AB. 100 equals 12 times this. 100 equals 12 times 12 square 144 minus 3Q. Hundred cancel one set of, so it becomes 4, this becomes 3. Sorry, 25 and 3. 25 equals 3 into 144, which is 432 minus 9Q. Or 9Q equals 432 minus 25. 9Q is 407. Q is 407 divided by 9. Whatever that turns out to be. So once you know a plus b and ab, you can find anything that can be expressed in terms of a plus b and ab. And so a square plus b square, a cube plus b cube, a power 4 plus b power 4, 1 by a plus 1 by b, 1 by a square plus 1 by b square. All of those you can find once you know a plus b and ab. And very routine question. Try this one. Okay, a couple of minutes and then we'll solve this one. X square minus 12x plus k equal to 0 has real roots. The modulus of k is less than 15. How many integer values can k take? It's a counting question. We'll have to say k can be this, that, and the other, and list everything down. That's one aspect of it. And then we use one unit of quadratic equation, some number system, some counting, mixed bag. No outstanding concept, but 3-4 ideas put together. So x square minus 12x plus k equal to 0 has the real roots. Quadratic equation has real roots. What does this mean? This means our discriminant is greater than or equal to 0. Discriminant is b square minus 4ac, or minus 12 whole square minus 4k greater than or equal to 0. Minus 12 whole square minus 4k greater than or equal to 0. 144 minus 4k is greater than or equal to 0. 144 greater than or equal to 4k, k less than or equal to 36. Mod k less than 15. And so we already know that mod k is less than 15. This expression tells us k is less than or equal to 36. Modulus of k is less than 15. So obviously k cannot be 35, 34, and all that. Modulus of k is less than 15 means k can lie between minus 14 to plus 14. It talking about only integer values, nothing more than that. It cannot be minus 15 or lower. It cannot be 15 or higher. All of these values satisfy this, or effectively we just need to worry about this. How many integer values are there? 14 negative numbers, 14 positive numbers, then that beautiful 0 or 29 possible integer values are there. Okay. Very regular, very routine question. You have to be careful with simplifying, solving, and remembering the 0 and making sure you worry about negative and positive. Know the discriminant funda, all of that. But then conceptually, nothing here. So be clear about that. You look at this question, say real roots, discriminant greater than or equal to 0. Plug that equation, find something, find the range of k, then go to if mod k less than 15, solve that as well. We're pretty much running out of time, so I'm going to stop out here. Come back to the real screen, have a quick chat, and then be done with it. So remember the wonderful questions. Set up this is a very simple topic, quadratic equation. Linear equation and quadratic equation are simple topics. So get lots and lots and lots of practice for this. Remember that this is a regular topic, so it's about the drill. It's about how quickly you can knock something off. So you need to have lots and lots of practice for this topic and know the basic ideas. Right? Just an outline about how we plan to do this, how we're going to think about just going forward. We're going to give or take one topic a week. We're going to pick a topic, announce it on Thursday or Wednesday or Thursday online on our Facebook group. So you can build up to that, practice that, do the basics, If you have access to a good course study material, use that, or go to online.2m.com. That's some other ship. And so that's amazing content. The massive advantage of learning on the product there, it's heavily modularized. So here you have to pause and play and solve. Where this everything's on bite-sized chunks. So you can learn fun fast, practice a little bit, step up and do tougher questions and be game ready. So the whole thing is put together like that. So once you know what the topic is, you have access to it, go through that. Hit the topic very clearly. Be ready for the Saturday evening class, where we'll not go through some diddly basics, but do something slightly more challenging, slightly more interesting, so that we can engage on thinking about the cat level questions, not very regular, simple plain vanilla questions. So if you follow that drill, we'll pretty much cover, give or take, everything quant and DALR through the next 5-6 months. Keep it in. Best wishes. Have a good weekend.